Hello students, I am back with a new video and today we are going to see operation on rational numbers. Before I start, my name is Santanu Das and I have been teaching from the last 27 years and I will try to make maths easy for you. Let's start. So about operation of rational numbers, operation on rational numbers, we'll take various examples to understand what are the different kinds of sums that can be asked. So we'll start with a very basic example. Minus 2 upon 3 minus 5 upon 3. In case of rational number, it's basically a fraction. So while solving rational numbers, what is necessary is the denominator should be same. So as you can see in this first example that we have taken, the denominator is already same. So my work is done. That part I don't have to consider. As in the previous video we saw, there are two signs between the numbers. So first we'll consider it. We will make it into one sign. That is going to be minus 2 upon 3 minus plus 5 upon 3. This thing we have covered in a previous video about how to do addition, subtraction. You can go back to the video and see it. You will understand what I'm speaking. So in this case, as you can see, the denominator is already same. So it's like a normal sum, how you do for integers, normal sums. You solve the numerator part. There's a minus and a plus, opposite sign. So you minus 5 minus 2 is 3. And then put sign of the bigger number is plus. So you write plus or it's understood. And then you just write down the denominator, whatever it is. In the case of this example, they are getting divisible. So the final answer is 1. Next example we'll take in which the denominators are not same. I am purposely taking two signs so that it will be a revision of the signs also, because students get confused about signs. So as you can see, in the previous example, the denominator was same, so it was quite easy to solve. You just had to solve the numerator. But in this example, the denominators are not same. So first of all, let's write it in one sign. 5 upon 7 plus minus is minus 2 upon 21. Now the denominators are not same, so we can't solve it. So first we need to make the denominator same. Now if you see it carefully, 21 comes in 7's table. So what we are going to do is, we are going to multiply 7 by 3 to make it 21. And as we have multiplied the denominator by 3, so we have to multiply the numerator also by 3. So what we have got is 15 upon 21 minus 2 upon 21. Now as the denominator has become same, so we can solve it. Plus minus is minus, 15 minus 2 is 13. Bigger number is 15, it has got plus sign, so plus 13 upon 21. So that's how we'll do a sum in which it's a multiple. Let's take an example. Now the next example that we'll see is where it's not a multiple. Suppose I take minus 3 upon 23 plus 4 upon 5. Now as you can see, 23 and 5 are not multiple of each other. So first, whenever it's not a multiple, the denominators are not multiple of each other, we need to take the LCM of all the numbers. In this case also you could have taken the LCM, but as the numbers were quite simple, we did it directly. But even in this case, if you would have taken the LCM, how do we calculate LCM? LCM of 7 and 21. So 7 and 21. While taking the LCM, we divide all the numbers, 2 numbers, 3 numbers, whatever kind numbers are there, by prime numbers. You just have to take prime numbers. You can't take composite numbers. 7 ones are, 7 threes are, and it already has become 1. So 1, 1. So we go on dividing till we get 1 at every place. So 7 threes are 21. So LCM is 21. So we know the LCM is 21, means in the denominator we should write it as 21. So here already there is a 21. Here you don't have a 21, so we multiplied it by 3. In this case, we need to find out the LCM. As it's not a multiple, any way you can do it. If it's a multiple, if you know your tables well, you can directly take the multiples like we did in this one. But when it's not a multiple, or you're not understanding whether it's a multiple or not, always take the LCM. So 23 and 5 LCM, as 23 is a prime number, 5 is a prime number. 5 ones are 23 doesn't come in 5's table, and 23 ones are. So the LCM is going to be 5 into 23. It is 5 threes are 15, 115. So what you should have in the denominator is 115. So there's 23. So what we'll do is we'll multiply it by 5. So when we multiply the denominator by 5, we need to multiply the numerator also by 5 so that we don't change the value of the sum, plus 4 upon 5 into 23 to make it 115. Multiply this by 23 and 23. So what we'll get is 5 threes are, it's a multiplication, minus 15 upon 115 plus 92 upon 115. See again, the denominator has become equal. So now we can solve it. Minus plus is minus, 92 minus 15 is going to be 77 upon 115. That would be the answer. Now, these are the three possibilities of the sums. Now, what we'll do is we take a sum in which there are more than two fractions. So, in that case, how do we do it? 3 1 upon 6 minus 1 upon 12. So what we did in this sum is we have taken more than two rational numbers. Let's make it more challenging. Suppose we have got say a normal number, an integer. Say we take it as 3. Now, as you can see, there are three fractions, that is rational numbers. 3 is also a rational. These are a natural number and 3 rational numbers. So we have to take the LCM of all of them. So before we take the LCM, what we need to do is, as we see, one of the numbers is in form of mixed fraction. So we need to convert it into vulgar fraction first. So 6 3s are 18, 18 plus 1, 19 upon 6. And this is 2 sign, let's make it 1 sign, minus minus plus, 1 upon 12 plus 3. Nothing is written below it, so we'll consider a 1. So this is a thing. Again, to solve it, the denominator should be same. But as the denominator is not same, what we'll do is we are going to make the denominator same. For that, we have to take the LCM of 21, 6, 12 and 1. You don't need to because it will have the same LCM. Let's divide it. 3 7s are, 3 2s are, 3 4s are, 7 1s are. 7 is not divisible by 2 and 4. Just write it as it is. 2 1s are, 2 2s are, and 2 1s are. So the LCM number is 3 into 7 into 2. These are the factors. So 7 3s are 21, 22 and 22s are 42. 84 is the LCM. So as we have got the LCM 84, so denominator, all the numbers should have 84 in their denominator. So how will you do it? 5 upon 21 into 4 is going to be 84. So we have to multiply by 4. Yeah. The next one is 19 upon 6. How will we get 84? We have to multiply it by 14. Some other people find it confusing to how to multiply. How do we know it? So where you have found out the LCM, you can check that 3 2s are 6 and what is remaining is 7 2s are. So it's 14. So the numerator 14 plus 1 upon 12. So into 7 will give you 84. And here into 7 plus 3 upon 4. There is nothing written. So into 84 into 84. So the answer is 5 4s is 20 upon 84. Minus, we have to multiply this, 19, 14, 9 4s are 36, 3, 7, 19, 6, 16, 266 upon 84, 7 upon 84, and 84 3s is going to be 4 3s are 12, 8 3s are 252 upon 84. So as the denominators are same, now we can take all of the numbers together. So it's going to be 20 minus 266 plus 7 plus 252 upon 84. Now you do it. These are two big numbers, minus 266 plus 252. Minus plus is minus. So that's going to be minus 14. Minus 14 plus 7 would be minus 7. And minus 7 plus 20 is going to be plus 13. So the final answer is going to be 13 upon 84. I solved it orally. You don't need to. You can calculate it besides in the rough and find out the answer. So the answer is going to be 13 upon 84. That's going to be the final answer. What we'll do is we'll take one last example which contains many operations in one single sum so that you understand how to solve those kinds of sums also. Divided by 10 upon minus 51 plus 2 integer 1 upon 3 minus 15 integer 7 upon 9. So the difference between the previous examples and this example, as you can see, we have a division also in it. Now we have seen in our previous video about BODMAS, how you have to be careful about the order of solving calculation. So in case of BODMAS, division comes first. So we are going to solve this first. So what we are going to get is 13 upon 17 into division. First we need to convert into multiplication. So you have to take the reciprocal of it and the rest of them write as it is. But as this is in the form of a mixed fraction, let's convert it into a vulgar fraction. 3 2 is 6, 6 plus 1, 7, 7 upon 3. And this one, 15 9 is going to be 135. 135 plus 7 is going to be 142 upon 9. So let's solve this part. 17 3 is 51. Anything else is cancelable? No. So the final answer is going to be, now let's multiply numerator by numerator and denominator by denominator. 13 3 is 39 and 10 1 is 10, and minus is going to be plus 7 upon 3 minus 142 upon 9. Again the same problem, that the denominator are not same, so we need to make it same. That is, we'll take the LCM of 10 3 and 9. 10 3 9, 5 2s are, it's not divisible, 2 1s are, 3 1s are, 3 3s are, and 3 1 1, 3 1s are. So all have become 1. So the LCM is 5 into 2 into 3 into 3, that is 3 3s are 10, 90 is the LCM. So what we'll do is, to make, we should have in the denominator we should have 90, so we have to multiply this by 9. We'll do it in the next step so that it doesn't become untidy. 10 into 9 and 10 into 9. In the case of 7 upon 3, we have to multiply it by 30 into 30. It's what, 42 upon 9. You have to multiply this by 10 to get 90, this by 10. So this is going to be 9 9s are 81, 8, 9 3s are 27, 35, 90, 37 is 210 upon 90, and 1420 upon 90. As you can see, the denominator has become same. So now we can take all of the numbers together, 351 plus 210 minus 1420. So solve it separately. 351 plus 210 is 16561, and this is plus. We need to minus 1420 by 5 because plus minus is minus. So it's going to be 1420 minus 561. So that's going to be 9 5 8. It's going to be 859. Yeah, 859. So it's going to be 859 upon 90. Now as you see, few numbers were in the form of mixed fraction. So final answer also we should write it in the mixed fraction. So how do we write the final answer in the mixed fraction? For that we need to divide it. 90 divided by 859. So it's going to be 90 9s is 810 and the remainder is 49. So it's going to be 9 integer, the quotient that we have got, upon the remainder is 49, 49 upon 90. So this is the final answer. Hope you have understood what we have solved over here and it is really helpful for you. Any questions you have, you can type it in the comments and I will try to help you out. Thank you for watching the video.